Okay, I think we'll get started. Good afternoon, everyone. My name is Rob Fitzpatrick. I'm with White Star Software, and we're talking about OpenEdge Diagnostic Data Collection. Pretty large database, about 1.7 terabytes, 1,800 users, all shared memory, and big L of 1,000,000. And this is the way that we had the Diag event parameter configured initially. So log table 3, VIT hold 3, system error 3, and again 3 means we're going to collect summary and detailed VST files and also generate ProTrace files. So we put this in and waited, and we didn't have long to wait at this site where they had chronic log table overflow issues. We had an event the next day. Well, not just an event. This is a part of a directory listing from the Diag. So you can see the timestamps here: 12/11/01, 12/11/03, 05, 05, 05, 07. So in the span of a few seconds, this was 7 log table overflows. But it gets worse. So 4 minutes later, we were up to number 114, which is pretty extreme. You don't normally see log table overflows happen this frequently. So what was going on here? It turns out that in this site they had purge jobs in the application, and there was a parameter in the application to specify a batch size on the purge. So a larger batch size means we're deleting more records in one transaction and therefore using more of the log table. And the creative user had figured out, well, I've got a log table of 1,000,000, so I'll use just less than that, thinking, I guess, that they were going to purge more records at once and run faster. The effect of that, of course, is that while that purge is running, as it goes through more and more records, it's effectively lowering the size of the log table for everyone else down to from 1,000,000 to 3,000. So it wasn't that user who actually caused the log table overflow. It was everyone else's activity who were suddenly constrained into a tiny log table, even though the code they were running was good. Even using a small number of logs when you've got 1,800 people is going to chew that up pretty quickly. But it got worse from there. As I said, we were generating ProTraces for each of these clients, and with 1,800 shared memory users and this many log table overflows, one on average about every 2 seconds, it was just signaling these clients over and over again, generate a ProTrace, etc. And so these clients became unresponsive because that's all they were doing was generating ProTrace files. The ProTrace is very useful because it contains your APL call stack, so that tells you what code were they running at the time of the event. That's critical to solve the problem. But the clients became completely unresponsive, so they decided to intervene. These clients aren't working, so we should just kill them. Unfortunately, as you can see, there were lots of system error events. We got 247 system error events in a span of 28 seconds. Why? Because when they killed the clients, they decided to use kill -8, which is SIG FPE. So if you're not familiar with that, that means floating point exception. And what does Progress think of a floating point exception? It's a system error. And we're also generating diagnostic data for system errors, so that just poured fuel onto the fire. Lesson learned. If you've got, number one, don't use kill -8. just kill the client. Number two, be careful about the logging level that you use for system errors, especially with ProTrace generation, because unlike some other events, they can come in bunches. There are a lot of different things that are classified as system errors, so you want to be judicious with the logging level on those in particular. So I mentioned the log table summary. This comes from the _user log VST. So here's what the file would look like if you just looked at the CSV file. Again, you get one record per user. And it's not the nicest thing to try to look at it and figure out, especially when it's got, 1,800 lines in it. So I wrote a little parser for it that kind of gives a nicer view of the data, and this makes it very clear who the culprit is. It was this user 1253 who used 997,266 logs out of the million. And you can see that there are these two columns over here for procedure name and debug line number. And what that is if you're using a feature called client statement cache and it's enabled, then in theory, that data will be written out as well to the CSV files, and then you'll be able to see the procedure name even down to a method or function or internal procedure name and the line of code from the compiled debug listing of the program. So you'll be able to see who is the user, what program were they running, what line of the program were they on. So you can hand that to a developer and say, here's your bug, please fix. Unfortunately, in this case, even though we had CSC enabled, the data was not in the file. So I believe that's a DDC bug because we were also getting diagnostic data from Proton, and it had the CSC data. So, and I've tested this, that the data is actually in the underscore connect. It just didn't show up in the CSV file for whatever reason. Sometimes we get data in here. It's not that it never works, but it was enabled for all these users, and none of them had this data, so I'm not sure why that happened. So, even though we didn't get that data, the CSC data in the CSV files, because we generated pro traces, we had the ABL call stacks for all of the users, and we were able to identify the offending program and get that fixed. It turned out there were more events later and there were more offending programs, but those have all been passed on to development and fixed, which is nice. So more lessons that we learned. It's a nice feature that you don't have to have separate diagnostic directories. If you have separate databases, you can consolidate them all into one place. And the path to the database will be in the tracking file, so you can determine which database it was and take the appropriate action. Just be cautious about, again, if you use the detailed logging on the log table event, because those files can get very large if you have a large log table, and you really don't need that data unless you need to know which table were the logs taken in and what were the rec IDs of the records that were being locked. If you really care about that, then yeah, you want the detailed level, but typically the summary is enough. Unfortunately, however, given the way that the event levels are structured, you can't capture pro traces unless you also capture summary and detailed data. So if you want pro traces, you have to have all of the VST data for that event. Again, as I mentioned, for system error event type, I would recommend a lower logging level and not to generate pro traces unless you feel that you really need them. Again, this is going to vary based on scale, right? If you've got a tiny database with 50 users, yeah, go nuts. It's probably going to be okay. But when you get into many hundreds or thousands of users, there's this multiplicative effect. It would be nice if we could configure DDC to only generate pro traces for some users, like whoever triggered the BI threshold event, or whoever had the top X% of locks. And Tom Bascom actually submitted an idea to the ideas portal on that, so hopefully product management will consider that. And also to throttle the events, so if there are a large number of events in a short time, then don't log data for all of them. That would be nice too. That's another idea that's been submitted. But yeah, be careful about the pro traces because they can render the the application inoperable in the worst case. We actually had to reboot the database ultimately in this case. So again, for the lock table overflow event, we found that the summary from the user locked VST was enough to figure out which was the problematic session. But without the protrace, you're not necessarily going to know which program to look at to resolve the problem. You could get around that by using client statement cache, but in this case, that doesn't always work. If you want to know more about the client statement cache, incidentally, the next session in this room is Tom Bascom, and he's talking all about this feature. And it's very valuable for diagnostics as well, so stick around for that if you want more info.